So this is the first page of the Unit 4 notes. So in this unit, we're going to look at bonding, specifically ionic bonds. So there's a picture at the top here that shows the two different main types of bonds that we're going to focus on. In part 1 of Unit 4, we focus on ionic bonds. And in ionic bonds, an electron is taken from one atom and given to another. So we actually have a transfer of electrons, a give and a take. In the second half of the unit, we'll look at covalent bonds, and covalent bonds are when the electrons are shared. So they're put in the middle, and both elements get to kind of feel like they own those electrons. They may or may not be shared equally, but they are shared. So just as kind of a reminder before we get going more into bonding, compounds versus elements. Elements are things that are on the periodic table. So an element is a substance that consists of one type of atom found on the periodic table. Examples would be anything from here. So carbon is an example, hydrogen, oxygen. So that's just a couple. You could pick, any of the 118 that are on the periodic table that I have printed. A compound, on the other hand, is a substance that is made of two or more types of atoms that are held together by a chemical bond. So if elements are kind of like letters in the alphabet, then when I take multiple letters, multiple elements, and I stick them together, then we're going to get words. And that's essentially what a compound is. So for example, H2O, which is water, is hydrogen and oxygen bonded together. That's a compound. Table salt is sodium chloride, which is the elements sodium and chlorine bonded together. We could keep going. Those are two that are really common and familiar. Glucose, C6H12O6 is a form of sugar. So all those are examples of compounds. When we look at these formulas, these numbers that I wrote down low, like the 2, the 6, the 12, these are called subscripts. So remember, subscripts, sub means down low, and then script just means writing. So subscripts and formulas indicate the number of each atom that is present. And if we don't write a subscript, then that just means 1. So for example, here I wrote Na, that means 1 Na. I don't have to write the number 1 because if I wrote Na, that means it's present, it's there. So we just default to that being a 1. So for example, in glucose, C6, there are 6 carbon atoms. H12, there are 12 hydrogen atoms. And O6 has 6 oxygen atoms. Those subscripts tell us that. If I have subscripts, but they're outside of parentheses, like we see down here, then that is going to affect all of the atoms that are inside of the parentheses. So for example, in NH4, that whole chunk is in parentheses, and then it says 2. What that really means is that I have NH4, but then I have NH4 again. I have that whole NH4 chunk twice, and then I have CO3. So when I look at it that way, and I wanted to figure out how many nitrogen atoms, I could write it out in kind of the longhand and count them. So how many nitrogens here? 2. I could also use distributive properties from math. So I see that right here there's 1 nitrogen, but if I needed to double it because there's a 2 outside of the parentheses, then 1 times 2 would get me 2. For hydrogen, if I look over at my longhand, I had 4 and another 4. That would be 8. If I wanted to use distributive properties from math, I have 4 hydrogens, and then that got doubled. 4 times 2 is 8. For carbon, I just have 1 carbon. That didn't get doubled or anything. And then oxygen, there's just 3. Okay. All right, so for this next part, it's asking just for oxygen, so you don't have to count how many of all the elements, just oxygen. For this one, we're trying to figure out how many oxygen atoms are in each of these formulas. So if you take a second, you look through these and try them, and then you can check. All right, so O4 should have been pretty easy. The next one here, the oxygen is in parentheses. So there's 1 oxygen here, but then outside the parentheses there's 3. So that means there's 3 oxygens. And then over here I have 2 oxygens, but then outside the parentheses there's a 2. So 2 times 2 would be 4 oxygens. All right. So from there, we're going to go ahead and define each of the types of bonds. We did the first 2 already at the top of the page, but we're going to put it here a little bit more officially. So in an ionic bond, electrons are going to be transferred. 1 atom gives, 1 atom takes. So they're going to be transferred, and that happens when we have 2 specific types of elements that are bonding. This happens when we have a metal. Metals are located on the left side of the periodic table. Remember that metals want to lose electrons to become like noble gases to get the octet. And so if I have one element that's willing to lose electrons, I want another element that's willing to take them. And the elements that will take electrons are nonmetals. So if I have a metal and a nonmetal, I have an ionic bond. Just as a reminder, there's the stair step on the periodic table. The elements that are over here are metals. The elements that are over here are going to be nonmetals. So that stair step's our dividing line. So if I have an element from over here, so I just pointed at chromium, and it's bonding with an element over here, I'm pointing at fluorine, that's going to be an ionic bond, a metal and a nonmetal. If I were to pick 2 elements that are both over here, like oxygen and fluorine, that would not be an ionic bond, because that's not a metal and a nonmetal. All right. Covalent bonds, which are also called molecular bonds, these are going to be made of 2 or more elements that are willing to share electrons. And that's going to be if I have 2 or more nonmetals. 2 plus nonmetals, I don't have enough room here, share electrons. So they both want the electrons, but neither will let go. So they both say, I want your electrons, and they stick them in the middle and share them. Okay. The last type of bond is a metallic bond. Metallic bond is pretty self-explanatory. It's made of metals. So 2 or more metals that have free moving electrons. This is called the sea of electrons. So essentially what happens with a metallic bond is you have a whole bunch of metal atoms, and it's really just the nucleus of all those different atoms. And then all of these are their little electrons, and these electrons are like the sea or like the ocean, where if a wave comes, they can all get pushed to one side, and then they can all get pushed back to the other side. And this is why metals are really good conductors of heat and electricity, because if you were to plug this into the wall, the electrons could flow through the metal. And same thing with heat. It just allows for the easy transfer because of these free moving electrons. At the bottom, we have 10 different formulas that are written out, and we're going to identify for each of these if this is an ionic, covalent, or metallic compound. So just as a reminder, for ionic compounds, we're looking to see is it a metal and a nonmetal. So metal and nonmetal. For covalent bonds, these are nonmetals only. And then for metallic, it's metals only. So we want to look at the formula and figure out, do I have one of each type of element, or do I only have nonmetals or only metals? So with CO2, I'm going to find C and O. These are both on the right side of our stair step. That means both of these are nonmetals. If they are both nonmetals, that means that it's covalent. I'm just going to abbreviate that. Next, we have NaCl. So I'm going to find those 2 elements. Na is over here. That's on the left side of the dividing line, so that's a metal. And then chlorine is over here. That's on the other side of the dividing line. That's a nonmetal. So if that's a metal and a nonmetal, that's ionic. Next up, we have Pb. Pb is lead. So lead is over here. When I look at that, that's going to be on the left side of the dividing line. So that's a metal. That's the only thing that's written. So if I just have a metal, this is going to be a metallic bond. And I just wrote Pb, but it's really just a whole bunch, maybe millions and millions and millions of lead atoms that are all clustered up together. We don't write like Pb 1,000 or a million or a trillion, because we always write the simplest formula. And the simplest way to write that it's just lead is to write Pb. Okay. All right, for these next 7, you're going to go ahead and try these. So pause here and try those, and then you can come back and check your answers. All right, hit play, and you're listening now that you tried them on your own. So H2O, hydrogen, even though it's on the left side of the dividing line, remember hydrogen is the one element that should be over here that's a nonmetal. So nonmetal, and then oxygen is also a nonmetal. So this is covalent, because hydrogen's weird, should be on the right side. Next up, we have calcium and carbon and oxygen. That's 3 different elements. Calcium is a metal, carbon is a nonmetal, oxygen is a nonmetal. So I said that I have a metal and 2 nonmetals. That's going to fall into the ionic category, because it's not just metals or just nonmetals. Fe is just an element. It is on the left side of the dividing line. That's metal, so that's metallic bonding. Next up is just oxygen. So if I have just oxygen, that's on the right side of the dividing line. That's nonmetals only. Nonmetals only means covalent bond. Beryllium and nitrogen. Nitrogen's a nonmetal. Beryllium's a metal. So metal and a nonmetal means ionic. S and O, those are stacked right here. Those are both nonmetals. If they're both nonmetals, that's covalent. And lastly, aluminum. Aluminum is on the left of that dividing line. It's a metal, so that's a metallic bond. All right, that's the end of page 1 of our notes. So we will pick up in the next video looking at page number 2, continuing to talk about ionic bonds and looking at how ionic bonds, the formulas of how they're written.